Hello, good afternoon, everyone. Welcome once again to our discussion on the topic of partial derivatives. So, this time, class, I'm going to present to you another way, the concepts of partial derivatives using some materials from another source. Okay, let us have this definition. Let f be a function of two variables x and y. The partial derivative of the function f with respect to x is the function denoted by the following notations. So we have here four different notations. So we have d1f, we have f1, we have f of x, we have partial derivative of f with respect to x. To represent this partial derivative of f with respect to x, such that its value at any point with the coordinates x and y in the domain of f is given by this. So d1f x of y, x and y equal to the limit of f of x plus h y minus f of x y divided by h as h approaches to 0. Alright, so this partial derivative of the function with respect to x is denoted by this expression here. So if the limit exists, so it means that we can use this definition provided that this condition is satisfied, that the limit exists. For example, if we're given here the problem that is find d1 f of xy. So a, we are given the function of x and y equal to 4x minus 4xy cubed plus 1. So using the given expression a while ago, given definition, so we just change x. We just change x to x plus h. All right, for the first term of our numerator here. Okay, so using this formula, just change x here to x plus h. All right, then after that, you just um, combine similar terms. Then you do factoring, and you will see this. Okay, so we have here 4x. So for our x is x plus h. So we substitute x plus h for our 4x. Okay, then since you have 2x here, so x is equivalent to x plus h, then you factor out x plus h. So what remains is the 4 and y cube, right? It's just like you just factor this out. When you factor out x, so you have 4 minus y cube, right? Then you factor x, then you substitute x plus h, 2x, so you have this. Then plus 1, then minus the whole thing. So the whole thing is this one. In our formula, this is equivalent to this one. Okay, you substitute it here, then multiplying this negative for each term, then simplifying, so we'll get this. Okay, so this one arise after you remove this sign of groupings here, then make use of this sign here negative, so it means you have to multiply negative 1 each of these terms here, or you just distribute first the x and then multiply this for the resulting number of terms on this part here. And after that, combining similar terms, then you combine similar terms, like for example this one here. When you remove the sign of grouping here, this positive, this becomes negative because this negative here. So you have negative 1, you have plus 1. So the 1 and the positive 1 here and the positive 1 here, which becomes negative, will be equal to 0 when you combine them. All right, then after manipulating some of this, or after simplifying some of these terms here, so you just multiply this each term. Okay, multiply, then combine similar terms. When you combine similar terms, you will obtain this. Okay, then you have h and h at the denominator. So h divided by h is equal to 1, which is equal to limit of 4 minus y cubed as h approaches to 0. So therefore, your final answer is equal to 4 minus y cubed. Okay, so I think it's very easy class because we had learned this before when we discuss about limits. So I hope you can still remember them. If not, then just try to review them in order for you to be able to understand how this problem is being solved. So another problem is we're given this and still we are asked to find the d1. So d1 means the partial derivative of the function with respect to x. If this is d2, it means that the derivative of the function with respect to y. Okay, since we are asked to find the the d1 uh, function of x and y, so this is just the limit of, so using the formula, x plus h y minus f of x y divided by h as h approaches to 0. So again, you just substitute x plus h for x here. So when you substitute x, so for this part, so we have x where our x is equal to x plus h, then you square that one, then minus 5y, then minus, so this one which is equivalent to this. Okay, then you remove the sign of grouping here when you multiply negative to each of this term on this part. So this becomes 5y, negative 5y, this becomes positive. So negative 5y plus 5y, so 0. Okay, so when you expand this one, we have a term here, x squared, then 2xh plus h squared. So the x squared here, positive, will be combined with this negative x squared, so that becomes 0. So the resulting numerator is something like this, 2xh plus h squared divided by h as h approaches to 0. So the numerator you factor out common, which is h, then you have h at the denominator. So the result will be something like this, 2x limit of the quantity 2x plus h as h approaches to 0. So therefore the answer is 2x. Okay, so that's the long method in finding the partial derivative class of a function of two variables x and y in this example. And then we have another definition here. Let f be a function of two variables x and y. So the partial derivative of f with respect to y is the function denoted by the following. Okay, now we have the subscript here, which is 2, that refers to uh, our partial differentiation is with respect to y. All right, so we have d2f, f2, f sub y, d sub 2f, f sub 2, f sub y, or partial derivative of f with respect to y, such that its value of, at any point xy in the domain of f is given by this. D sub 2f of x and y equal to the limit of x. So this time class, ry is the part that is added to or added with h. Unlike in the d1, the x here has a plus h. Okay, but here for the second term it's the same. Then we have the same denominator as h approaches to 0. Okay, so again, we can use this definition provided that the condition here that the limit should exist is satisfied. Okay, so for example, find the partial derivative of f with respect to y. So we're given this function of two variables. So using the symbol, so equal to, so take note because if you are differentiating partially with respect to y, so we are going to hold the other variable constant. Okay, but before we do the shortcut, let's solve this problem using the long method. Okay, so using the formula, so we have here the limit of function of x and y plus h minus f of xy divided by h as h approaches to 0. So again, to solve this problem using the long method, we have to substitute y plus h for every term that has y. So in this case, we have y squared here, so change y to y plus h. So you change here y to y plus h. Okay, so we have 2x is a 2x. So we have 2x here. Then we change y to y plus h. Then we have squared. So we also have to square this. Then plus 5 y plus h. Okay, because our y is equal to y plus h. Then minus f of x and y. So it means the right side of this equation. So you substitute it here. All right. So we have this. Then after that, um, you can expand this one, or yes, you can expand this one. Then after that, you combine similar terms, so then simplify. So after expanding, and after combining terms that are similar, so you have this result. Okay, so we have this resulting expression. Then you can factor out common here, which is or if you just do the factoring here, so common is common, we have h. All right, so you have h here. So factoring out h, and then you have h at the denominator. So the numerator, the common factor, the numerator which is h, and the denominator which is h. So h divided by h is equal to 1. So what is left here is, because what is left is this one is it has h. Then when you factor this out, so no more h. So here we have h, we factor out, so you have only 5. So but here in the second term there's still h, but as h approaches to 0, so that the second term here becomes 0. So that's why the resulting partial derivative with respect to y is equal to 4xy plus 5. Okay, another example. So we are given this expression, and we are asked to find the value of the uh, partial derivative of the function with respect to y at this point. Okay, so you just use the result. You have, because we're given the same class, right? So we're given the same, and you're asked to find the value of this partial derivative of f with respect to y. So what you're going to do is just substitute the value, because here we have 4xy plus 5. This is the result of our uh, partial differentiation process. And then you are asked to find f2. F2 is, it means you have to find the derivative of this with respect to y, which is the result is 4xy. See this one, 4xy plus 5. Then after that, you substitute the values of x and y. So minus 1 and 3, you substitute to the result here, and then you'll have the final answer. All right, so another definition, let p function of x1, x2, and so on and so forth until xn be a point in r to the n. So this is no longer a plane. No? This should be a 3 or 4 or 5 and so on and so forth dimensional space, and f be a function of n variables x1, x2 until xn. So the partial derivative of f with respect to x sub k is the function denoted by dkf. Okay, so it depends on this number here, such that its function value at any point p in the domain of f is given by this. So similar to the previous definition, except that we have so many terms here. Okay, and you have here x1, x2, and so on and so forth, xk plus h, and you have xn minus f function of p divided by h as h approaches to 0. So in other words, class, our given function is a function of more than two variables already. So that's why we use here the general representation. Be a point n r n. N here is the degree, the degree of our function. It can be a quadratic function, it could be a cubic function, and so on and so forth. So again, we can use this expression as long as the condition that the limit exists is satisfied. Now let's have another examples here. Let f have x and y equal to 3x squared y minus 4y to the fourth plus 7. So find f1 x y and f2 xy. In other words, class, for f1, we need to find the partial derivative of the function with respect to x. So 1 here corresponds to x, 2 here corresponds to y. It means that here we are going to take the partial derivative of given function with respect to y. Okay, so 1 here is that we are differentiating partially with respect to x. 2 here indicates that we are differentiating partially with respect to y. Alright, so for our solutions, so differentiate with respect to x. So it means that we have to hold one of the variable, that is y in this case, as constant or fixed. So treating y as constant. And then just apply the same rule in differentiation class. Okay, so therefore we have our answer here. So the partial derivative of the function with respect to x, that is f1, equal to, so because y here is treated as constant, so if this is constant, 3, so 3y, you segregate 3y, then you just take the derivative of this x squared in applying power rule. So the 2 will go down, multiplied by 3, so it becomes 6. Then the exponent, this one is 1. So we have 6xy. Alright, so for the first term. Okay, then minus. So y is constant, so this is constant. So you're differentiating this part here. So we have this is y is constant, so we are differentiating. You segregate this one, then take the derivative of x with respect to x. So the derivative of x with respect to x is equal to 1. 1 times y to the fourth. So that's why we have here minus y to the fourth. And then the derivative of this constant is equal to 0. So finally, this is our answer. Okay, now differentiating with respect to y. So this time we are going to treat x as a constant. Alright, so treating x as a constant. So again, we are going to use the same. So this is 3 is constant, x is a constant, so x squared is also constant. So now we have to differentiate only y. So derivative of y with respect to y, okay, is equal to 1. So 1 times 3x squared. So our first term here is 3x squared. Okay, how about the second term? For the second term, so x is constant, so it means we take the derivative of this, so applying power rule. So power rule of fourth, y to the fourth power. So 4 will go down, so multiplied to x and y. So we have 4xy, and the power now is 3. So 4y cubed. So this is minus. So we have the second term here, minus 4xy cubed. Then again, the partial derivative of the constant is equal to 0. So these are the answers, class. Okay, so I hope you were able to follow it. Now, so another example, let a function of three variables, with three variables x, y, z, equal to z to the fourth times e to the minus x squared minus y squared. So we're given this function of three variables x, y, and z. So now we are asked to solve for g1. G1 means we have to find the derivative of this function with respect to x. G2 means we have to find the derivative of this same function with respect to y. So 2 here corresponds to y. And G3 here is partial derivative of the given function with respect to z. Okay? So listen carefully, because this is a very easy problem, class. But if you forget the basic concept and differentiation, you will still find it hard to understand. Okay, for our solution, so first you need to write down the given. So this is our given function. Okay, sorry, you just do the differentiation immediately. So we have g1 of this function. So it means we are differentiating the function with respect to x, because we have here the subscript equal to 1. Okay, so since we are differentiating the given function, the given function with respect to x, then the two variables here, y and z, should be held constant. All right. So um, with respect to x, so this means that this one is a constant. That's why we just write it in this way, and then take the derivative of e to the, so it is in the form of e to the u. So remember that the derivative of e to the u is equal to e to the u, right? So you just copy this one. So you may use the formula, the derivative of e to the u, derivative of e to the u. You can use this. So the derivative of e to the u with respect to x. So we use this symbol, equal to e to the u, e to the u times the derivative of u, derivative of u with respect to x. Okay, so that's why here we have, since this is constant, so you segregate this, then just take the derivative of the e. So our e is e to the u. You just copy this part here, then take the derivative of u. So e to the u, so u, derivative of u, so meaning the derivative of this part here. Okay, so take the derivative of this with respect to x. So again, with respect to x, so this one is again held constant. So you just have to take the derivative of this, the partial derivative of x squared, which is equal to 2x, right? So that's our answer. So that is negative because this is negative here. Okay. Now, how about G2? So you may rearrange, or you may just opt to put your answer in this manner. So G2, so this time, you just take the derivative of the given function with respect to y. Okay, so we have to hold x and z as constant. All right, so holding x and z as constant, so we have here, so again z is a constant, so again we have e to the u, so we just copy this one and then use this formula. All right, so e to the u, so since you are differentiating it with respect to y, so it means that x is constant, so this is constant, so derivative of constant is 0, so we just take the derivative of this, right, which is negative 2y. Okay, so that's our G2. So just the product, you can rearrange. You can write 2y first here, or you just opt to put your answer in that manner. How about G3, G sub 3? So we are now going to differentiate this with respect to z. So with respect to z, it means you have to treat x and y as constant. So x and y and constant. So it means this one here is already, this is e is a constant, the exponent considered as constant, so therefore the whole thing here will be our constant, meaning this whole thing here will be our constant if we solve for g sub 3. So in other words, you are going to differentiate only z to the fourth. So that's why you have, so if you differentiate z to the fourth, we apply power rule, so the power will go down. So that's why we have only 4z, 4z cube. Then you just copy this one because they are considered as constant. X as constant, y is constant, e is constant. So e to the constant, e to the power constant, so the whole thing is constant. So that's why we have just copy this part here. And then we just differentiate this factor here. Okay? I think that's all. I hope you were able to follow it. And we have another example. That's the application of the arctangent. Okay? So I want you to practice this one class and let's compare our answer, no, as I discuss the continuation of this topic later on. So I'll end this video up to this part and I'll continue it in another video to make it short. Thank you and see you again in our next video. Bye. God bless everyone.